Hello, my name is Douglas Rumbaugh, and in this video I want to talk a little bit about a subject that I've been thinking a hell of a lot about lately, and that is languages of instruction. So what programming languages should be used for teaching first-year programming students how to program? Specifically in this video, I want to talk about one language in particular and why I think that it is not a very good language of instruction, in spite of the fact that it's seeing more and more use for that purpose. So when I was in undergrad, the language of instruction for most of my degree was C#. And I like C#. It's not a bad language, and I can talk more about it later. But towards the end of my stay there, my end of junior, beginning of senior year, there was a change in leadership in the department, and the new leadership wanted to change directions. And the impetus for this was that when you look at, say, a basic Hello World program in C#, there's a lot going on in such a simple program because there's a lot of extraneous, I'm going to use the word fluff, that surrounds that one line of code that actually does something. Right, so in C#, if you're not familiar with it, it's a lot like Java. You have some inclusions at the top. In C#, the keyword is using, and then libraries. So in order to be able to access the method to write to the console, you have to include the system library, so using system. And then you have a namespace declaration and a class declaration, and then your main method, static, void, main, string array args. And then you finally get down to the line of code that actually does something, console.writeLine, hello world, and then you have a gajillion closing curly braces to close out all the scopes. And when we're looking at this sort of thing from the viewpoint of somebody who knows programming, so me, when I look at that, it's not that big of a deal, right? There's not much going on there. It's really just one line of code, and you can easily cut through the crap, so to speak, and get down to what's actually happening. But if we step back and look at this from the point of view of somebody who has never seen a program before in their life, there's actually a hell of a lot going on there. And as an instructor, you're stuck doing something along the lines, the slightly hyperbolic lines of, well, this is a library inclusion. We'll talk about that next week. Ignore that for now. It doesn't really mean much for us at this moment. Namespaces and classes, those will come up halfway through the semester, maybe a week before the midterm, whenever we force you to throw away everything you've learned up to that point about programming and relearn it from an entirely new paradigm. And then we have a method signature here. We're going to talk about those later too. Some of that crap gets thrown in with object-oriented. There's a data type there. We'll talk about that later. Don't worry about that array thing. We'll talk about that in data structures later. But yeah, so then finally we get down here. So we have console dot. Don't worry about what that is. It's not important right now. WriteLine is the name of the method you're calling, and then there's some parentheses. There's some quotation marks and some text, and the text in the quotation marks tells you that it's a string, and the parentheses associated with the method call. And then we end the line with a semicolon. And all lines in C# will end with semicolons, except for those that don't. And that is the Hello World program. So of course that was very dramatic, and it's explained a lot better than that. But there's a lot that sort of goes into just that very basic overview of here is Hello World. Contrast that with Python. So in the Python programming language, it is literally one line. Print Hello World. Of course, Hello World in quotes. And it doesn't matter what kind of quotes. In C#, of course, the single quotes versus double quotes mean two different things. In Python, they don't. So, right, it's one line. You look at that, and you get right down into it. Python also has an active shell that you can use. So you can type print hello world, press enter, and boop, hello world comes back. You can say a equals 5, b equals 6, a plus b, boop, 11 pops out. So in that regard, Python is very good at this sort of thing. And that is the language that my department decided they were going to pursue, was doing all instruction from the ground up in Python. It's a decision that I disagree with. I, in spite of those two advantages, don't see Python as that great of a learning language. The reason for that, there's several actually, and a lot of it comes from the fact that I'm rather old school. So I'll talk a little bit later in a different video about what I think would be a good learning language, because I have some pretty strong opinions about that. But back to Python, I actually had to teach a programming class to a number of freshmen who had never programmed before. And this was after the switch. So I've taught a programming class with C#, and then I had to later teach one with Python. And so where to begin? Data types. We'll start with data types. That's the low-hanging fruit, right? So for those of you who don't know, Python is implicitly typed. It's more or less static, but it is implicit. So what that means is that when you declare a variable, you do not explicitly type in the data type. You don't say int a equals 5. You just say a equals 5. And in doing so, Python interpolates the fact that we're putting 5 in there, and 5 is an integer, so therefore a must be an integer. And as a result, you never actually write a data type name into your Python program. It's actually really neat when you think about it, and it lends itself to a lot of really cool things. So, for example, your formal parameters on functions, those are all data type lists as well. It's just, add a comma b. But that turns that method generic automatically. You can pass in 5. You can pass in 5.0. You can pass in 3 plus 4i as a and or as b, and it will just work. Now, if you pass in a string or you pass in the letter a, then you'll get a runtime error. So that's one thing, one nasty side effect is that because of the way that this type thing works and the fact that Python in most implementations is handled as interpreted rather than compiled, a lot of these type errors that crop up at runtime. They're not caught by the compiler because there really isn't a compiler in most cases. And that can be very frustrating. That from an actual using Python in a production environment, that becomes very frustrating when you suddenly get a type that just, 1 in a million, this particular resource returns a data type that you've never seen it return before. And suddenly it just passes through the program just fine until it gets to this one critical point, and then boom, runtime error. Whereas if everything were fixed, explicit, statically typed, that you'd get a compile error right away. But anyway, we're talking about teaching. So there's that where you get those runtime errors. But also, try teaching the importance of data types in an environment where the programming language is in many ways doing its hardest to hide the existence of data types. It's not easy. And I don't think that the benefits that you gain in terms of ease of use and whatnot from having it being implicitly typed like that, where you don't have to think about data types so much, I don't think that that's worth it in the context of a first programming language that you're teaching somebody how to program with, because data types are important, and we don't want people to get lazy about data types. When you're using Python, you have that option. You can become very lazy very early. When you're using something like C#, you'll get compile errors, and you have to be careful. And that enforces those good habits, which you then can transfer into Python once you're more familiar with this idea of data types and so on. There's other things like, for example, 32 versus 64-bit floats and integers. In Python, it's really tricky. Unsigned data types. I think it's important from at least an academic standpoint to get familiar with unsigned arithmetic and working with unsigns or floats versus doubles and so on in Python is not straightforward, if at all, if it's even possible. I'm not sure if you can do unsigned integers in Python or not. I haven't actually looked that up. But those are all important things. Yes, so data types. In addition to that, and this is an issue, I'll just do one more because we're getting a bit long here, and then I'll cut it. Python, I found, plays very fast and loose with scope. So what I mean by this is, if you're inside, we'll restrict ourselves to considering the body of one function. Right? So our scope consists of this function and a global scope outside of it. So what can wind up happening that's very frustrating in Python is if you declare variables in a subscope. So say we have our method, and then inside that method we have an if statement, and then inside that if statement we declare a variable. Say a equals 5. In most programming languages, that a, because it was defined inside of that if statement, only exists inside of that if statement. And as soon as you're done with that if statement and pop back out into the function, or the main function scope, it disappears. Python doesn't necessarily work that way. And so you can't really teach that kind of scope using Python, which is really bad in my opinion, because scope like that in a language like Java or C# or really any enterprise level programming language is a very real thing. It's a very real thing. And to try and teach basic programming to students in a language that doesn't really support that level of granularity with scope, it doesn't work, because you can't do it. If the language doesn't respect scope in that way, then there's no way that you can really teach it, or at the very least enforce it, because even if you do say, never do this, the programming language will still let them do it. So the fact that it doesn't support scope like that it boggles my mind. And between that and the variables, it's just missing too many important in-your-face elements of programming to really, I think, be justifiable as used in this context. That's to say nothing of garbage collection. I'll talk about garbage collection later. That's a whole other can of worms. But yeah, so I really, truly don't think that Python is particularly well suited as a first programming language for students who are just learning how to program. Because of that, it skips out on a lot of stuff. Which makes, for example, me as a fairly experienced software developer, it makes my life a little bit easier because I can play fast and loose with certain things. Whether that's a good idea or not further down the line, but it's an option. And I know enough to be able to select to use that option or not to use that option, and to be very careful to avoid it. But when you're teaching, what you're teaching is almost as important as almost as important as what you're trying to teach are the barriers erected around that. Because those barriers, they help to define what you're trying to instruct, and they also help to restrict your students' abilities to screw things up. And if the option to make this particular kind of mistake doesn't even exist, then they won't be able to make that mistake. And that does kind of contradict the point which I'm going to make in my other video, my follow-up video to this on the languages that my preferred first programming language. But I think there is, and I'll talk about that more in that video, there is sort of a distinction between the two, making mistakes, the two different kinds of mistakes that you can make. In any event, I don't want to ramble for too much longer. So that is my opinion on Python and why Python I don't think makes a very good first programming language. I'll be interested to hear what you think. Do you agree with me? Do you disagree with me? Why or why not? Throw a comment down there. It'd be a very interesting conversation to have, and I think it's a conversation that's very much worth having. So that is my piece for this particular day. I hope that you enjoyed this video. I hope you found it useful and or entertaining, and I hope that you've had a wonderful day so far and continue to have one. So I will see you again in the next one. Goodbye now.